So in this second part, we're looking at rock pocket mice across 35 kilometers of the Arizona Sonoran Desert, which included both dark rocky lava outcrops and light rocky granite areas. And they recorded the substrate color and coat color frequencies for each location. So substrate is like the surface that the mice are living on. Now each site was separated from any of the others by at least 8 kilometers. The researchers trapped a total of 225 mice, and their data are summarized below. So if you look here at the substrate color, so here's light substrate, and then we also have another light substrate here. So when we talk about the numbers of mice, what we can see is in these total mice right here, they're divided in between light and dark colored mice. And so that's how you read this chart. So for example, in the collecting site number 1, there was only 6 mice collected, and it just so happened that all 6 of those mice were light. If you look at the area like collecting site number 4, it was dark, so lava rock. There were 5 mice collected, and they were all dark. So that's how you would read this data. So it says here, calculate the overall frequencies of light-colored mice and dark-colored mice caught on light-colored substrates. So our first step is we want to find that data in the chart. So we're looking for the overall frequencies of light and dark-colored mice on light substrates. So we want to find the total first. So we have these numbers to look at. So we're going to want to add 85 plus 6 plus 77. So our total number of mice we have are 168. And now it says calculate the number of frequency of light-colored and dark-colored mice. So if I look over here, I have for the light, so I look at these numbers, I have 86 plus 34. So if I do that math, 86 plus 34, I'm looking at 120 mice. So 120 mice had light fur. And then the remaining mice, if I go back to this, dark, I have 5 right here and 43. So now I'm looking at 48 with dark fur. So now the question asked us, though, it asked us about the frequency of light-colored mice and the frequency of dark-colored mice. So I'm going to take this 120 light-colored mice, and I'm going to divide it by the total. And that'll tell me the frequency, or how often, or how much of the population was light color. And I calculate that it's about 76%, or 0.76 of the mice. And when I look at the frequency of the dark, I'm going to take 48, and I'm going to divide 48 divided by the total of 168. So with that, 168 mice, we find that approximately, sorry, I just caught a mistake. It's not actually 76, it's 71%. So then when my numbers didn't add up when I was trying to multitask here, so when we do 48 divided by 168, we find that about 29% of the population is dark colored that have been caught on the light substrate. So now here you can see the different frequencies of this. So here, the frequency of light colored mice, and then you have the frequency of dark colored mice on the light substrate. Then question 2 asks us to calculate the overall light-colored mice and dark-colored mice caught on dark substrates. So we do the same exact thing. So the total number of mice caught on dark, here we have 12 plus 45. So our total population of mice on dark is 57. And when we look at the total caught, it looks like in this one, all 12 were dark and 42 were dark. So if we look here, 12 plus 42, we see that 54 out of 47 mice caught had the dark phenotype, so 90, that equals about 95% of the mouse caught on dark lava had a dark phenotype. The remaining 3, that frequency is about 5%. So here, when we look at, let me just double check with the math, 3 divided by 57 is approximately 5%. So here, the frequency of light-colored mice only happens about 5% of the population trapped, and then in this one it's about 95%. Oops, not 98, 95. Okay, so let's go ahead and see what, we look here and check our work. That's correct. So now, using the Hardy-Weinberg equation and the data from the table above, determine the number of mice with homozygous dominant and heterozygous genotypes on the light rocky granite. So in the light rocky granite, if we go back to our thing here, in the light rocky granite, our population size was 168. And our mice with the light phenotype, there was 120. So we've already calculated this. 71% of the population has a light phenotype. That is our Q squared. So our Q squared, the frequency of mice with the homozygous recessive would be 0.71. Now we need to find, though, our P and our Q in order to calculate the homozygous dominant and the heterozygous. So if our Q squared, I'm just going to make some space here. If Q squared is equal to 0.71, we can find Q. We're going to take the square root of 0.71, and Q is equal to 0.84. So that means that our P would be equal to 0.16. So now when the question asks for the heterozygotes, we're going to go 2PQ, which is basically 2 times 0.84, or actually 0.16, times 0.84. And if we do the math for that, that should give us our heterozygotes. And we find that the frequency of heterozygotes is approximately 27%. So now we're going to find our P squared, and P squared is equal to 0.03. If we take our P squared, 0.16 times 0.16, because we're squaring it, so our P squared, our homozygous dominance, is equal to approximately 0.3. Now here we see some rounding errors, because if you remember, our formula, P squared plus 2PQ plus Q squared should equal 1. So you can always double check yourself. These numbers should be close to about 1. So right here, 0.03 and 0.27 is about 0.3 plus 0.7. We're at 1.01, which is pretty close, and that would just be due to rounding errors. So if we go back to here, we have our frequency of the homozygous dominant is 0.03, and then in our heterozygotes, it was 0.27. So now let's go ahead and calculate these numbers on the dark lava substrate. So we want to find the frequency of mice with the homozygous recessive. That's our light-colored fur mice. So here, our total population size was 57 mice. So if we had 57 mice total, and 3 of them had the light phenotype, we're looking at here, we know that this is equal to our Q squared. So we want to find the square root of this. So here, if I take the square root of both sides, I find that Q is equal to 0.22. Now because P plus Q equals 1, I know that my P is going to be equal to 0.78. So when the question asks for the frequency of the homozygous recessive on the dark colored substrate, My answer right here is 0.05 because it's about the individuals. And I used that number to calculate my P and my Q. So now we can find our heterozygotes. So 2PQ is going to be equal to 2 times 0.78 times 0.22. And when we type that into our calculator, 0.78 times 0.22 times 2, we find our heterozygotes are 0.34, or roughly 34% of the population. Now for our P squared, which represents our homozygous dominance, we would take our 0.78 times 0.78, and we find that about 61% of the population is homozygous dominant. And if you add up these numbers, they should equal about 1. And they do. Okay, so if we go back here, this would be 0.34. And then for our homozygous dominant, we have 0.61. So 61% of the mice trapped there. Oh, I did that backwards. I'm sorry. So here we have our 0.61. And then our heterozygous, we have about 34% frequency is heterozygotes. And then here is the answer key. All right. Now, when we look at these questions, which fur color seems to have the greatest overall selective advantage? Use data collected from both dark and light color substrates to support your answer. So when we look at our data here, we can go back. It looks to me as if the dark color phenotype has the greatest selective advantage. And the reason I use that data is because in this number, only 5% of the mice trapped have light phenotype on the dark, whereas on the granite substrate, roughly 30% up here, roughly 30% actually have the dark phenotype. So on the lava rock, if we look back at our mouse, the lava rock, it's you can kind of survive as a dark phenotype on the granite, but having the lighter phenotype on the lava is greatly selected against. Or you could say that having a dark phenotype on the lava is highly selected for. So if we go back to this question and we look at what they're asking, it says, which fur color seems to have the greatest overall selective advantage? I would say the dark phenotype on the rock lava has the greatest survival. And then here, that's what the their answer says too. So, and according to the film, wet environmental change gave a selective advantage for one coat color over another. The presence of lava, as lava shows up and hardens into dark rock, all of a sudden now having a dark phenotype would have an advantage. And so that mutation would be selected for. And question 8, to determine if the rock pocket mouse population is evolving, explain why it is necessary to collect fur color frequency data over a period of many years. Well, remember that evolution is a population change over time. So you need data to compare it to, and therefore you want to see how this population is changing over many generations. Okay, so good job, guys.